What we have here is a severe mixture. Hello folks, Dave here. I'm currently in the process of upgrading my solar workshop with a new inverter and an off-grid power system. In this episode, I connected direct solar power to my workbench, completed the install of solar-powered workbench lighting, and added a small power board with a fuse block to the workbench, and a few other bits and pieces. I also tried out my GoPro, which I got off of eBay used, and hope that it will improve the quality of the videos. I hope you enjoy this episode. Thanks for watching. Today we're going to look at the wiring situation in the solar workshop. I'm building an off-grid power system that's going to power a lot of stuff in here, and in the process of doing that I need to get a hold of all these wires that are just absolutely everywhere. Over the years I have installed a lot of cables in the solar workshop for solar power, for lighting, and so forth, and it's become quite a mess. And a lot of this was done during times where I was having severe health problems. I still do. If it's a mess, it's a mess. Otherwise you get no wires at all and you get no power. And that's why you have things like that, which are just done in a great hurry with what little time is available. And as you can see, I'm starting to install cable management along the backside of these beams, which are going across the ceiling. And this is going to be a really big help in getting the wires cleaned up. I'm going to run them overhead. I'm also going to use what is called electroduct. This is a wire hider cable management solution, and that should hopefully solve a lot of the issues with wires running absolutely everywhere. What we have here is a severe mixture of both a laboratory and research environment as well as permanent installation. Right there is a main breaker from one of the solar panels I have. They're 100-watt solar panels. It used to be 2. I'm going to be upgrading the power today that's feeding into that breaker. There's the PV cable which comes in from the outside. I'm going to tie into this with another breaker, and I'm going to run that overhead through that cable, and it's going to make a left turn, come right up here. I'm going to install some wire hider or electroduct right along there, and it's going to come all the way down here, make a left turn, and drop straight down to the workbench. And the workbench is going to have direct solar power running straight to it. I do this for all of my workbenches. They all have direct solar power. And in order to accomplish that, I'm going to use a board. It's going to be used to create a power board, which will have a fuse block, a circuit breaker, fuse block, USB charging, all that good stuff. It's all going to be installed behind the workbench. I will have to cut this board to fit probably. And I think it will go right about here. All the cabling will then be hidden using electroduct, and you can actually see right here I've got some overhead lighting that I installed, and that was a night and day difference when I started using the overhead LED lights. That's 18 watts of LED lighting. Well, the first step is to get the overhead cables run. In order to finish the wiring install, I need to go ahead and open these channels up here. Hope you can see those. And the wires will go right in here. There's going to be quite a few more wires before I'm done. We'll see how that goes. Got plenty of room for more cables when I add them. And this one here is a little bit under tension. It's a work in progress. I'm going to be tightening these up a little bit more. We'll see how that goes. Okay, it's not pretty, but that cable there is going to be hidden. It's a work in progress. It takes time. It's coming right along here, and then it drops straight down, and I've already tinned the ends with solder. And that's going to drop straight down to probably this area here if I had to guess. Okay, I need to find a fuse block, and I thought I had something like that. These boxes, some of them are empty. Yeah, this one here will do. This is a 12-volt fuse block, so we'll use that. And we have also these things. These are pretty useful. I'm going to use that for the negative side. Alright, let's DIY. Just go ahead and mount this board up here for now. And there's my Ryobi battery charger. It's running straight off of solar. Just plugged right in the back there. And that goes over here to a solar panel. You can see it charging. 16 volts, 1.7 amps. It's actually got a boost converter, so the voltage is going to be much higher than 16 volts. This is one of my favorite possessions. It's not a toy, it's a real charger. And you can plug any DC source, including a solar panel, right into the back. I think Ryobi ought to make these by default, but they don't. Not that I'm aware of. Okay, here's the solar power equipment board I'm building for the workbench. This is going to allow me to have solar power and solar panel feeds coming into the workbench, circuit breakers, workbench lighting, 2.1 millimeter power plugs, and also USB charging, all integrated on one board. I'm going to put the fuse holder on there and several other things as well. I also ordered some USB power boards that are on the way. They're a few bucks each, and I'm going to mount those on here as well. Okay, so to build the solar power equipment board for the workbench, that's basically a board that holds all the circuit breakers and fuses. I'm going to add this fuse block, and then I'm going to have my negative come in through here. The power wires will come in from the top, and they might come in through the back of the board, and then the negative will tie in here. The positive will tie into this fuse block, and then I can add all my USB, my power connections, and have those fused individually, just to make sure I don't have a problem if I short something out. So the fuse block will be right here. I'm going to say right about here will be fine. I'm going to put one screw in there for now just to get things started. Alright, there's my positive side of my bus. The solar power is going to come down into here. There's my negative side. Now I need a place for the wire to come in for the main power feed. I'm probably going to have more than one, but I'll start with one for now. So have it come in right about here. Now I'm going to bring in the wire overhead, and that's going to feed this power board. Alright, there's the power board. I gotta hide the wires. That's gonna be a process there. Alright, it's not big enough, so we need to increase the opening there for the wires. Alright, there's my power wires. The wires are now alive, so let's do a polarity check. Alright, so this one here is positive. Getting 17 volts. Let's get some heat shrink to mark that positive wire so I don't accidentally burn something up. Alright, we'll use this temporarily. I can do something better later on. There's the positive, and I need a washer for this power block here, fuse block. Okay, I'm just temporarily hooking up the positive feed to the fuse block using a washer. I will have to properly terminate these connections at a later time. And this is the negative side. It's going to go into the negative bus bar. Now I have solar power at my workbench, as I always do. And that will allow me to charge phones or do whatever I need to do. I have a lot of different things that I use direct solar power for, also known as PV to load. And this is just a tip of the iceberg. I need to go ahead and get some fuses for that. Alright, let's do another polarity check just to make sure I don't have it backwards. And the polarity looks to be correct. Now I can go ahead and connect temporarily some alligator clips so that I have power on the workbench. I'll get a fuse later. Actually, I had it backwards already. You can see why I have to be careful. Alright, let's tie temporarily with these alligator clips into the bus bar and the fuse block. And that power will then come out of here. And the next order of business is to take this 2.1 millimeter that I've temporarily connected to alligator clips and plug it right into my E600 LFP. And we should be able to get some power now. Let's see if that starts charging. There it goes. 6 watts, 10 watts. Not going to get a lot right now, but it's going to help. Alright, so we have a temporary positive and negative connection point. This is for a 100 watt solar panel, or possibly two 100 watt solar panel arrays. This is to bring utility power to my workbench. I do this on all my workbenches. There's going to be USB charging, there's going to be power connections, there's going to be a voltmeter, and of course I'll tie that into the E600 solar power input through a fuse, of course. Right now I'm getting about 18 watts, which isn't very much, but I'm also running these lights. So if I unplug those, and it goes up to like 37 watts. So it's basically doing math. It's subtracting the lights. When I plug these lights in, of course, it's using some of that power, and so you get less charging. Makes a lot of sense. Now there's one more order of business I need to do, and that's outside. I need to upgrade the solar power installation. And for that, I've been using a novel and strange method to attach solar panels to the side of my building, and I'm going to show you that. I've got another panel ready to go right here. If I can get it out without knocking all this stuff over, that would be great. And hopefully without breaking it. This is a 12-volt solar panel. And I'm going to go ahead and put that outside. So let's take this solar panel outside. All right, here's all the solar panels. And I'm using a new method to attach them, and it's magnets. You can see right there I've got some magnets on the panel, and they're rubber. I'm testing them out. So far they're working well, and this allows me to quickly add new solar panels if I need to, just for experiments and so forth. You can see these solar panels aren't getting anything right now. That's the problem with wall mount. It really limits the power. But it's a nice convenient way to add power for experiments and other things like that. Now I'm going to go ahead and mount this solar panel. Let's see how this works. I believe I will be adding 2 more magnets. I'm not sure yet. Yeah, I need to move it down, I think. It really is stuck on there. I'll need to straighten that out. But these skinny little panels, I like them for this purpose. I will certainly be adding more panels if I like the way this performs. In the meantime, though, I'm going to parallel it with some of these here and get myself some extra power. Well, I think I got it kind of straight, I'm not sure. And I'll probably move it later. So I'm just going to go ahead and wire it in order to get some more amps and watts into the shop. And I'll think about exactly where I want to place it later. And maybe I'll do some different wires or something like that. All right, let's see if they're wired up properly. Yes, they are. 16.7 volts currently. Alright, there's a look at the power board so far. We've got the blue voltmeter, LED voltmeter. I've got the wire hidden behind the board. Positive comes out here into a 2 amp fuse. I don't have any 1 amp fuses available yet. Those will eventually be replaced. I've got the negative wire coming out here, and I've got an alligator clip and a 10 amp fuse feeding my solar generator, which is right here. And unfortunately there's virtually no power available, so the voltage is bouncing all over the place. If I unplug the solar generator, the voltage will stabilize. That's perfectly normal considering the electronics inside these units. There is, however, still some power available, and I'm going to be using that. Solar generators on the market often have difficulty with low light conditions, and you can see that it doesn't really know how to extract power from the solar panel unless there's a certain amount of power available. It just kind of bounces the voltage around. It's not a problem, I'll just disconnect it for now. Alright, it's kind of awkward to show, but there's the LED lights, and there's 3 of them. They're all bolted up underneath the shelf there, and the wires, they all run up and down this piece of wood here, and they come over here, and they go into that piece of wire hider there, and then they come down here, and I've added another piece of wire hider here, and eventually I'll do something about this. I've got the solar generator clamped onto the 10 amp fuse. I've got a 2 amp fuse for the voltmeter. I've got another fuse here and a spot for 3 more. And that's getting me up and running. It's not complete, but it'll do the job for now. The next job will be to add USB charging, but those haven't come in yet. There's going to be a couple of USB ports here, actually about 4 of them, that I can use for charging whatever I want, running lights, charging my cameras. Eventually this alligator clip stuff will be removed. This is just here so I can charge my solar generator and have AC and DC power on my workbench. And now this board is going to get its first live use. You'll notice the voltage is down to 9.76 volts. That's because currently I only have a single 100-watt panel wired into this power board. Believe it or not, all the workbench lights are running directly off that 100-watt solar panel, PV to load. These alligator clips are temporarily attached to a 2.1 millimeter power cord over here. It comes down here, and instead of plugging into the solar generator, it's going straight to this connection here. And that is actually attached to my LED lights that are lighting up the workbench. So I'm referring to those hidden recessed lights that are underneath this piece of wood here. And so what happens is the sun comes out even a little bit, those lights come on, and it just works. There's no battery, there's no charge controller, there's no inverter. and I don't really have to do anything. In fact, there's not even a power switch on these lights. I've been doing this for several years now in my workshop. I may do some more video on that later. That's amazing. There's no battery, there's not much to go wrong. There's not much to pay for, you just need some LED lights and a couple of pieces of wire to hook them up. Now granted, they're not well matched to the solar panel under such low light conditions, and that's why it's dragged the voltage down to 9 volts. But who cares? It still lights up my workbench, I don't have to cycle my batteries, and it works. A real quick update on the off-grid power system upgrade that I'm doing. I've got batteries coming that are going to sit right here. They're 100 amp hour batteries, and I don't know how many I'm going to have right now. I'm going to start with at least 2, but there's going to be a lot more than that added. Again, these are going to be keeping the lights on in my shop, running my air conditioner, running my dehumidifier, running my computer, until I get the batteries that are going to go over here. But those are going to be a lot of work, and it's going to take significant time to get all those cells wired up, and to build shelves to go here to hold all the batteries, do all the wiring. In the meantime, my air conditioner and everything else is going to be powered by the system over here, and I'm not going to do away with it. I'm going to build this permanently, and we're definitely going to have some serious power here on this shelf, and I may actually add batteries down here as well, which indeed was the original purpose of this workbench. It was intended to be a battery shelf, and now it's kind of going to do both a workbench and a battery shelf type of function. This is the charge controller I'm going to start with. There will be a separate video coming out showing that, showing the installation of this equipment, and hopefully that'll be uploaded soon. One thing I look forward to when I get my batteries is the ability to run that thing all day off of solar power without any problem. Right now I'm pretty limited in what I can do with it, and it's getting very hot, so I want to go ahead and get this up and running on batteries as soon as possible. Off-grid air conditioning, yes, it's on the list. Here's a look at my off-grid solar-powered shed ventilation setup. That's a 12-volt DC brushless fan. It's doing pretty well. And of course I still have my car radiator fan. Currently it's turned off because there's not enough power to run it. I also added a 100-watt solar panel to boost the power to the shed and to run those fans a little bit better. Probably will eventually do something better than this. It's feeding another 3 to 4 amps of current into my shed, and it helps run my fans. The 24-volt solar-powered ventilation fan in my other shed is also running very well. Of course, there's not much sun right now, so it's really struggling to move any air. In any case, this fan is doing the job, and it's working very well. A better match to the 50-watt solar panel I put on this shed. There is a look at the 50-watt solar panel that's running the 24-volt fan, but it's not really getting any sun right now, so I don't really expect it to do much. I still have the 4 100-watt solar panels out here because I'm going to need those for an upcoming project, and I hope to start that project very soon. You should see 1 or more videos on that as soon as possible. That's my 1200 watts of solar that are out year-round, and I'm going to be doing a lot more with that. These are going to be running my air conditioning, my computer, my lights, and everything else. My future plan is to put some kind of a metal racking system out here, probably right in this area here, and get all these solar panels clamped to it and off the ground. I'm very tired of weed whacking and trimming around these panels, obviously. So I want to get some proper solar racking installed, but due to health issues and other things, a lot of times I just end up using a piece of wood and a brick. And of course, if you have a windstorm, those panels will just flip right over and be carried away. So this is very stressful. I need to get some metal racking as soon as possible. A really long time ago, I had installed an extra set of rails for solar panels that are wall mounted. However, that might be used in the future for a different project, or it might be used for mounting more solar panels. I haven't decided. In any case, stay tuned for that project. I'll definitely be using these rails to mount something. It just depends on how things go.